We are Group 7 and our presentation topic is about optical fibers. So let's start with the background history of it, and I separated them into 5 parts from 1840s to 1991. And the first part is from 1840s to 1881, which finding the properties of light. And in the 1840s, two physicists found that the light's traveling way may controlled by specific medium. A few years later, in 1854, a school teacher found that the light could be directed into a clear material. He used a container and a bin of light to do the experiment. The result was that the lights followed the pathway of water and a zigzag occurred in the bending part of the water. This demonstrated the total internal reflection of light and showed the properties of the light transmission. And after that, Alexander demonstrated a new invention, which is optical telephone system named photophone. And the photophone started popular worldwide during 1980s. It counted as the first mobile phone. So the second part is from 1920s to 1930s, the technology of transmitting an image through the optical fibers. And in 1920s, John came out an idea which is using microelectrode arrows with transparency to transfer the image for television. And after that, in 1930s, and other physicists found that a bunch of optical fibers can transmit picture and image. So the third part is from 1960 to 1961, more properties of optical fiber are found. In 1960, a helium-neon gas laser is invented. In 1961, American Optical announced the single-mode optical fiber, which is different from the multimode. Multimode optical fibers is better for short-distance transmission, but single-mode fiber is better for the long-distance transmission with laser dope. So it opened the door to the long-distance communication, such as the internet. The fourth part is from 1970s to 1975. The optical fiber are widely used in the society. And in the late 1970s, most of the telephone companies started to rebuild their communication infrastructures. They're using the optical fibers in the communication device, which can enhance the volume of information being transferred. And the final part is in 1991, the photonic crystal fiber was developed. I found that all the optical system can carry more volume of information than the cable with electronic amplifier. So the TPC5 fiber was widely used and landed across the Pacific Ocean. And that's the end of the background history of the optical fiber. And I'll pass the time to the next student to talk about the scientific principles.
Hi, this is Rachel from Group 7. Let's talk about the physical principle behind the scene. Okay, let's see. Now we have 4 major parts. The concept of waves, properties of lights, and total internal reflection and dispersion. Let's talk about concept of waves. Okay. What is wave? Basically, wave shows how the energy flows through the medium, but not the medium itself. And also, we can sort the wave into 2 types, the mechanical wave and the electromagnetic wave. A mechanical wave, just like the things usually affected by the gravity, just like a water wave, sound wave, or rope wave. And the electromagnetic wave is just like the light radio wave and microwave X-rays, etc. Okay, let's talk about the properties of lights. Mainly, the properties of lights has 4 different parts: reflection, refraction, diffusion, and absorption. But today, we're mainly talking about the major parts, about the reflection and the refraction. Okay, first of all, let's talk about reflection. What is reflection? Reflection is the common phenomena of all the light signals or even the waves that follows the real light incident signal bump into the surface. the reflected signal would just comes out with theta 1 and theta 2. And theta 1 is totally the same to the theta 2. Yeah. And let's talk about refraction. As for refraction, we can see that when a signal is going inside during different medium, the path of the wave signal will be different. We can see that theta 1 and theta 2 is different because the n, which means the refraction index, is totally different. And also, there is an interesting thing that happens in our daily life that most of the people think the water is shallow near the lake or the swimming pool, but it actually is very deep. That's because of the refraction rate of the lights in the air and water are totally different, which what the depth we see are actually the apparent depth but not the real depth, which is actually quite dangerous. Yeah. Okay, after that, let's talk about Snell's law of refraction. Easily, we can see that n1 sine theta 1 equals to n2 sine theta 2. And how to prove it? How to know that? Briefly speaking, we can see that from the trigonometric theorem, function theorem. We can see that as if this is 1 and this is also 1. And we can see that theta 1, sine theta 1 is bigger than sine theta 2, which means this thing is bigger and this thing is smaller. And because there's a equal sign in the middle of this, and we may see that n1 is smaller than n2, and that's how it works. Okay, after we learn about the Snell's law, let's talk about today's key point, the total internal reflection. Okay, as we can see, according to Snell's law, it's easily that when theta 2 gradually increases, the theta 1 will finally turn out to become 90 degrees. And when the theta is at this point, we can call theta 2 theta c, which makes the critical angle. And as for theta c continues to be bigger and bigger and bigger, the refraction would no longer exist. All things remain with just today's key points. Total internal reflection, and that's how the optical fiber work. Okay, last but not least, let's talk about the final problem, dispersion. What is dispersion? Frankly speaking, dispersion is an optical phenomena which will lead to different speed of every light beam due to the different wavelengths. And is there anything wrong with the dispersion? For sure, definitely. Because due to the different speed of the wavelengths, we may see that there will cause a signal lag. And the signal lag will finally turn out to be an error, which means the signal will overlap with each other. That isn't a good sign. For example, we can see that the computer signal usually combines of 0 and 1, but one day if 0 and 1 combines together, that doesn't mean anything. That doesn't make sense. That just means nothing, which means error. Okay, that's my part of my presentation. Thanks for listening. Let's take my time to Jiwon.
Hello everyone, I'm Steven. Today I will talk about optical fibers. There are several types of optical fibers. There's multi-mode and single-mode optical fibers. I would like to explain the word mode. What does that mean? It means that the number of type of light mode that can be propagated in the optical fibers. What does that mean? Simply, it means that the number of pathway that light can travel through the optical fibers. So multi-mode have multi-pathway and single-mode have only one pathway. What is their main differences? The main differences is their core diameters. The single-mode optical fibers have 9 micrometers core diameters, while the multi-mode fibers have 50 to 62.5 micrometers core diameters. You might think that, well, the larger the water pipe is, just like the optical fibers, the more the water flow is. So the single mode optical fibers should have less speed and less data transmit than that can transmit than the multimode optical fibers. But actually, that is wrong. The single mode optical fibers has no limited bandwidth theoretically, while the multimode optical fibers has a limited of 25,000 megahertz per kilometers. So they also have their maximum distances. The multimode fibers have 500 meters, and the single mode fibers have up to 40,000 kilometers, which is much longer. And they also use different light sources. The multimode fibers usually use LED only, and the single mode use laser diode. So why they behave so differently? And I would like to introduce two limiting factors: the modern dispersion and modern noise. So when we talk about the digital signals, we usually represent them as 1 and 0. And if we want to translate these signals to some optical signals, and we can and transmit through the optical fibers, we just represent 1 to switching off the light and 0 to switching off the light. And here's the problem: since multimode optical fibers have several light modes, which means that they have different time to reach to the end, it eventually causes the delay and out focus of the light sources, and this optical signal will overlap, while the single mode optical fibers will not. And great in-depth optical multimode fibers can help solve the problems. On the other hand, chromatic dispersion can also cause the delay and the bandwidth of the limiting bandwidth of the single optical fibers. And we know that light is the combination of different wavelength of electromagnetic wave. So when we have different wavelength, the light will spread out and cause some signal delay. And another factor is modern noise, which some moisture will affect the signals, and the moisture is in the optical fibers, and they will absorb it. As you can see the graph, there's some absorption peak, and the moist will affect the signals. So here's my end.
I'm going to talk about real-life application of optical fiber. So first is telecommunication. Telecommunication is used for transmitting and receiving, so it allows to connect faster and clear conversation. And then second is fiber optic thermometer, which is there's normal thermometer and fiber optical thermometer. And normal thermometer, if there is 2 points, then it only allows to check the temperature with only 50 meter and 100 meter. However, if you're using fiber optic thermometer, you can use 0 meter to 100 meter, which is whole area. So it has a huge advantage. And third part is networking. Networking is connecting users and servers in a variety of network settings. Also, in our own country allowed to connect other countries' server, and also increase the speed and accuracy of the data transmission, which is very important. These days, data has a lot of valuable things than other things. And then we can use these three things as a medical way. This is used as a light guides and imaging tools, and also as lasers for surgeries. So fiber optic cables are widely used in the field of medicine and research. Also, optical communication is an important part of non-intrusive surgical method. So Boris goal is searching for a back of bookshelf or under the desk that we cannot see visual way. And endoscope is also searching the area that we cannot see. However, endoscope is inside our body because diameter is thinner than borescope. And then also using broadcast cable companies are using fiber optic cables for wiring CATV and HDTV, internet, video on demanding, and other applications. So these three cables are connecting optical fiber and machine and all over the world. And then there is a fiber optic gyroscope, which is FOG, and there is a fiber coil that it allows to check where you are. And then this one has a like 100% energy restore in there because of the made by fiber. Also, this FOG using INS, which is inertia navigation system. This inertia navigation system is very important for airplane and missile and ships and submarine. These four things allow to check where you are and where you need to go and how much far is left for arriving. And then this is also used for sunlight concentrator, so it's possible to provide sunlight to everywhere people want. So this advantage is able to get sunlight even inside the buildings and underground. And then last part is about the future. Optical fiber future is very positive way because there is a silicon photonics technology in computer. So this tech computer is connecting chips and chips by Cooper. However, this silicon photonics technology is connecting by chips and chips by optical fiber. So Cooper lines was sending electrical signal. However, this optical fiber sending the light signal. So you can download like full HD movie by 0.8 second. It's really fast.